Hey everyone, here's Unit 12, Lesson 6, Central and Inscribed Angles. For the do now, it says points A and C are points on a circle with center at O. So remember, this is circle O. Circles are named by their center. It says identify the intercepted arc of angle COA. So if I highlight COA, we're talking about this angle here, and the intercepted arc is the arc that it opens up to. I kind of think of it like a Pac-Man. So it's going to be arc. So this symbol here represents the word arc, and then underneath it we write CA. Next it says draw triangle AOC. So AOC then connects C back to A. Explain why the triangle AOC is isosceles. Well, if we look here, OC is a radius, and OA is also a radius. And all radii of the same circle are congruent, which means this side and this side are congruent of this triangle. So therefore, this is an isosceles triangle with two congruent sides. All right, you might want to pause the video and just write that down. So segment OC and segment OA are radii of the same circle, which means that they are congruent. And a triangle with two congruent sides is isosceles. Describe the relationship between the measure of angle OCA, so this angle here, and the measure of angle OAC, which is this angle here. Well, guess what? Those are the angles across from the congruent sides. Therefore, these are the congruent base angles. All right, so I just rewrote the measure of angle OCA and the measure of angle OAC are congruent, and there's however you want to explain it. Angles opposite congruent sides of a triangle are congruent, or the base angles of an isosceles triangle are congruent. Now it says draw point B anywhere on the circle. I'm going to put it right over here, making it a major arc. So remember, a major arc is an arc that is greater than 180 degrees. So it says identify the intercepted arc of angle A, B, C. So again, here's the angle, and again, it's kind of like Pac-Man, right? It's opening up to the same exact arc. It's opening up to arc CA. Remember that symbol, like it looks like a rainbow, and then CA underneath it. Now it says describe the relationship between the measure of angle COA and the measure of angle ABC. Well, the angle COA, this is a central angle. And remember, the central angle is equal to its intercepted arc, in this case CA. The measure of angle ABC, well, this vertex is on the circle, making this an inscribed angle, which means it's going to be half of its intercepted arc of CA. So therefore, the measure of angle ABC is equal to half the measure of angle COA. So if angle COA is 50, that would mean that arc CA is 50, which means the angle is going to be 50 divided by 2, which is 25. So those are just examples. Example number 1. In each of the following diagrams of circle O, so that means O is the center, the measure of angle COA, O is the middle initial, which means O is going to be the vertex, which makes these three angles in orange central angles. And if that angle is 50 degrees, then remember the central angle is equal to its intercepted arc. So when they ask you to determine the measure of angle CBA, well, angle CBA in each one of these, notice where the vertex is. It's on the circle. That makes this an inscribed angle. It's a angle formed by chords whose vertex is on the circle, and therefore it's half of the intercepted arc. So notice that they both intercept arc CA. So therefore, in each of these cases, the measure of angle CBA is going to be 50 divided by 2, which gives you 25. 50 divided by 2, which gives you 25. Okay, so the inscribed angle is half the intercepted arc, and the central angle is always equal to the arc. So we fill in the blanks down here. The measure of an inscribed angle is half the measure of the central angle with the same intercepted arc. So the inscribed angle is half the central angle when they intercept the same arc. Example number 2. In each of the following diagrams of circle A, well, right there it means A is the center, determine the measure of the angle labeled X. So in the first one, it says the measure of angle D is 25. Well, angle D is this angle here whose vertex is on the circle and whose sides are chords, which means this angle is half the intercepted arc, which means the arc is going to be twice it. So therefore, this arc, BC, is going to be 50 degrees. So that means that the measure of this angle X, which occurs at angle BAC, A is the center, that makes this a central angle, and central angles are equal to the arc. Example B says the measure of angle D is 15 degrees. So that means the measure of angle D, so I'm going to highlight that. Well, this angle here is 15 degrees. And that angle is formed by chords and the vertex is on the circle. Therefore, the intercepted arc is going to be twice the measure of the inscribed angle. Remember, the inscribed angle is half, so the intercepted arc is double. It says find the measure of angle X. Well, there's a whole bunch of different ways of doing this. One way of doing this is you can see that BC is a diameter. And the diameter forms two semicircles, which means that there's 180 degrees in each of these semicircles. So one way of doing this is we have arc BC is 30, which means the rest of this arc forming the semicircle is going to be 180 minus 30. So 180 minus 30, which is 150, and this is a central angle, so therefore the central angle is equal to the intercepted arc. You could have also said that this is an isosceles triangle, so therefore the two base angles are 15 degrees. 15 plus 15 is 30, and the sum of the three angles of a triangle is 180 degrees. So you're still getting 180 minus 30. So depending on how you see it, write down some notes. And now we're on to letter C. It says the measure of angle BAC, A is the middle initial, that means that's a central angle, is equal to 90 degrees, which means arc BC is equal to 90, since the central angle is equal to the intercepted arc. Now they're asking me to find the measure of angle X, which is angle BDC, which is an angle formed by chords and whose vertex is on the circle. So the inscribed angle is going to be half of the intercepted arc, which is arc BC. So it's going to be half of 90, which is going to be 45 degrees. So the measure of angle X is 45 degrees. And last but not least, we have angle B, which is 32 degrees. Well, angle B is another inscribed angle, and we know the inscribed angle is half the intercepted arc, which means this arc is going to be twice 32, which is 64. Now it says find X. Well, X is inside this triangle here, which we know, since A is the center of the circle, we know that each of these two sides is the radius. And we know that all radii of the same circle are congruent. So what we can find here is we know that the central angle is equal to the intercepted arc. And now we have that the base angles of any triangle, isosceles triangle, are congruent. So here's your formula. So go ahead and solve it, and I will meet you back here with the answer. All right, so I did 180 minus 64 is 116, divided that by 2, and I got my answer to be 58. And then I wrote down isosceles triangle has two congruent base angles, which are located across from the congruent sides, and the sum of the three angles of any triangle add up to 180 degrees. Example 3 says determine the value of X. So I look at what did they give me? They gave me this angle K of 25 degrees, which intercepts arc HI. So I know that this is an inscribed angle whose vertex is on the circle. So therefore the intercepted arc is going to be double. Now they're asking me to find the measure of angle J, which is another inscribed angle that intercepts, look at this, the same arc. So therefore the inscribed angle is half the intercepted arc. So therefore inscribed angles that intercept the same arc are congruent. Fantastic. Example number 4 says given circle O, determine the following and explain. So why don't you go through this, pause the video, see what you can write down, and then meet me back here and we'll go over it. Pause the video. So I'm going to start with what did they give me? They gave me this angle BDC, which is an inscribed angle, and I know that the inscribed angle is going to be half of the intercepted arc, which means this arc is 2 times 70, which is 140. So when they ask me for arc BC, I know that the inscribed angle is half the arc, so therefore the arc is 2 times 70, which is 140. Then it asks me for the measure of angle BEC. Well, angle BEC is going to be this angle right here. So I'm just looking for this part of the arc. All right. So therefore, you can either say that it's half of 140 or inscribed angles that intercept the same arc are congruent. Either way, angle E is going to be 70 degrees. Now it asks for the measure of arc AB. Well, arc AB is going to be the rest of this arc over here. And if I look here, AC is a diameter, and we know that the diameter divides a circle into 2 semicircles. So therefore, arc AC is going to be 180 degrees minus the 140 that we've already used, which gives me 40 degrees. So when they finally ask me for the measure of angle BEA, which is this angle here labeled as X, I know this is another inscribed angle, so it's going to be half of its intercepted arc. So half of arc AB, which is 40, and half of 40 is 20 degrees. Excellent job. As shown in the diagram below in example number 5, this is a quadrilateral, which means it has 4 sides. And it's inscribed, which means that it's in the circle and all the vertices form inscribed angles because the vertices touch the circle, and all inscribed angles are half the intercepted arc. If the measure of angle D is 86, well then guess what? The measure of arc EG is going to be 2 times 86, which is going to give us 172. So in part A, where it says determine and state the measure of arc GFE, it's going to be 2 times 86, which is 172 degrees. Now it says determine and state the measure of arc GDE, which is the rest of this circle. Well, guess what? There's 360 degrees in a full circle. So we're going to subtract out that 172, leaving us with 188 degrees. So now it says determine and state the measure of angle F. Well, angle F is this inscribed angle, which intercepts arc, oh my goodness, GDE. So therefore, it's going to be half of 188 degrees, which is 94 degrees. Fantastic. One more question to go. Example number 6 in the diagram below of circle O, which means O is the center, chord CD is parallel to the diameter which goes through the center of the circle. Now, what's important for that? Since these two line segments are parallel, it means that the space in between this arc here and this arc here are going to be congruent. So when it gives you that the measure of arc CD is 130 degrees, well, the diameter forms 2 semicircles worth 180 degrees each. So we're going to subtract out the 130, and then that leaves us with 50. We're going to take that and divide it by 2, because these two pieces are congruent, which leaves us with 25 degrees, which is equal to the measure of arc AC. So arc CA plus arc CD plus arc DB is equal to 180 degrees. That's where I got that. Whatever arc CA is, which we don't know, is the measure of arc DB, and arc CD was 130 degrees. So that's just another way of showing it. So now you guys are going to do the independent practice, which is right here. So make sure you copy, complete the whole packet. Again, try these out, do the best you can, and when you're done, don't forget to take a picture of your work and submit everything to your teacher in Canvas. You guys are doing a wonderful job. If you have any questions, don't forget, please reach out and let us know what we can do to help you out. Have a great day.